Have you ever sat on a plane, looked out the window at that massive wing, and just thought to yourself, how on earth is this even working? I mean, how does this giant metal tube weighing hundreds of tons just hang out in the sky? Well, today we are going to pull back the curtain on the incredible science of flight.
I mean, that's the big question, right? It just feels wrong. It feels like it's got to be breaking some fundamental law of physics. But here's the thing. It's not. It's actually using the laws of nature in a truly brilliant way. And by the time we're done here, you're going to get it completely. All right, so here's how we're going to crack this code. First, we'll look at the constant battle of forces going on. Then we'll dive into the secret science of lift. That's the magic part. After that, we'll see how planes get moving in the first place, how pilots actually steer these things, and then finally, we'll tie it all together to show you what's really happening up there.
So to get how a plane flies, you've got to picture this. It's in a constant, invisible battle. It's like a high-stakes four-way tug-of-war, with forces pulling it in every direction all at once.
And here are the players in that battle. You've got weight, which is just gravity, always trying to pull the plane straight down. Fighting against that is lift, the upward force the wings create. Then you have thrust, which comes from the engines, pushing the plane forward. And working against that is drag, which is basically air resistance trying to hold it back. Every single moment of a flight is about managing this four-way fight.
And this leads us to the golden rule. It's simple, really. To go up, your lift has to be stronger than your weight. To speed up, your thrust has to be stronger than your drag. And if you just want to cruise along nice and steady, well, then all these forces need to be in a perfect, delicate balance. It's not static. It's a dynamic dance that's being choreographed every single second of the flight.
Okay, so thrust and weight, pretty easy to understand. Engines push, gravity pulls. But lift is where the real magic seems to be. I mean, how does a simple curved piece of metal create enough force to pick up something that weighs as much as a building? Let's get into it.
You know, for the longest time, people argued about this. Was it Bernoulli's principle, this idea that the curved top of the wing makes air speed up, creating a low pressure zone that kind of sucks the wing upwards? Or was it good old Newton's third law? For every action, an equal and opposite reaction. The wing smacks air downwards, so the air pushes the wing upwards. So who was right? Well, it turns out they both were. They're not competing theories. They're just two different ways of describing the same amazing thing happening at the same time. So scientists, of course, boiled all this down into a formula, and it really comes down to four key things. You've got the density of the air itself. Thicker air gives you more lift. You have the wing's surface area. A bigger wing can push more air around. Then you've got this thing called the lift coefficient, which is basically just a number that describes how good the wing's shape is at creating lift. But honestly, the last variable, it's the most important one by far. And that variable is velocity. Speed. And look closely, it's not just v, it's v squared. This is huge. It means if you double your speed, you don't get double the lift. You get 4 times the lift. Triple your speed, you get 9 times the lift. This is exactly why a plane has to hit that one specific, non-negotiable speed on the runway before you can even dream of getting off the ground. That v squared, that's the secret sauce.
Okay, so speed is everything. We get that. But how do you get a 500-ton machine moving that fast to begin with? Well, that is the job of thrust. And thrust comes from some of the most powerful engines ever built.
A modern jet engine is basically a controlled, non-stop explosion. It's a beautifully simple 4-step cycle. You can remember it as suck, squeeze, bang, blow. First, it sucks in a truly insane amount of air. Then it squeezes that air down to incredible pressures. Then it injects fuel and bang, ignites it. Finally, it blows all that superheated gas out the back at unbelievable speed. It's Newton's third law all over again. Throw a whole bunch of stuff backward really, really fast, and the reaction pushes the plane forward.
So, we're in the air and we're moving forward at incredible speed. Awesome. But, you know, a flight from New York to London isn't all that helpful if you end up over Brazil. You got to be able to steer the thing, right? And pilots do that by controlling the plane's movement in 3 different ways. First up is roll. That's the side-to-side tilting motion when one wing goes up and the other goes down. That's controlled by these little flaps out on the wings called ailerons. Next, you've got pitch. That's what makes the nose of the plane go up or down, which makes the plane climb or descend. And that's handled by the elevator, which is on the horizontal part of the tail. And finally, there's yaw. This is when the nose of the plane moves left or right, without rolling. Think of it just like the rudder on a boat.
And no surprise, it's controlled by the rudder on the big vertical fin at the back.
Now, pilots use a mix of all three, roll, pitch, and yaw, to steer. But here's the really cool part about modern jets. Pilots aren't actually pulling on cables that move those flaps. Instead, they're using a system called fly-by-wire. Their controls send a signal to a computer, and the computer figures out the safest, most efficient way to move the control surfaces. It's like a super smart assistant that makes the plane more stable and prevents the pilot from accidentally doing something dangerous. All right, we've gone through the four forces: the science of lift, the raw power of thrust, and the art of control. So now let's put all the pieces together for one final, mind-bending idea about what flying really is.
This quote absolutely nails it. See, an airplane isn't floating, it's not just hanging there defying gravity. The truth is, it's actually in a constant state of controlled falling. Gravity is always pulling it down. But because it's moving forward so incredibly fast, the wings are able to constantly grab a massive amount of air and throw it downwards. And that creates the equal and opposite reaction, lift, that keeps it from ever actually hitting the ground.
So flight isn't about being lighter than air. It's about being the master of the air. It's a nonstop, powerful, and incredibly precise process. The next time you feel that takeoff rumble, what are you going to be thinking about? The masterful act of redirecting the air, or just defying gravity? Hope you enjoyed this explainer.